Hello, grade 9s, and welcome to your last lesson of the year. Okay, so today we are moving on to another concept on factoring. Okay, now the assignment is going to be due on Friday because we have marks cut off, and report cards marks are due the following week. So you're going to have to get this in by Friday. Okay, so today's lesson is on factoring a difference of squares. Okay, now just like we talked about factoring trinomials 2 weeks ago being the opposite of FOIL, right? This is the opposite of a special product. Remember, product means to multiply. So the special product that we're talking about here is, in fact, a binomial that looks very similar in that x's, in this case, are the same as the first term. The last terms look the same, 5 and 5, except one is a positive and one is a negative. Now, when we FOIL this out, x times x is going to give us x squared. X times negative 5 is going to give us negative 5x. And then positive 5x times x gives us positive 5x. And then last terms is going to be positive times a negative, which gives us a negative. And then 5 times 5 gives us 25. So what we see happening here is, in fact, that we have two middle terms that are going to cancel out. Negative 5x and positive 5x gives us 0x's. And we end up with x squared and minus 25. So today we're doing the opposite of this. Remember, it's the opposite of special product. So we're going to start with the x squared minus 25, and we have to go backwards to what are the two binomials. Now, the easy way to be able to do this is just to recognize what one of these questions looks like. So it's going to be a binomial that we're looking at. Okay, and on that binomial, you're going to have to be able to take the square root of the first and the last term. So what is the square root of x squared? Well, what is x squared? X times x. So the square root of x squared is x. And what is the square root of 25? Well, 25 is 5 times 5. So the square root of 25 is 5. So we could take the square root of x squared and 25, okay? And the other thing is that there must be a subtract between the terms. That means right here, there has to be a subtract. It does not work if there's an add. So you must be able to take the square root of the first term, there's a subtract, and you have to be able to take the square root of the second term. And that's just being able to recognize that this is, in fact, a difference of squares. Okay, now, there are going to be some cases where we're going to have to remove a GCF. Okay, whenever we're factoring, we always look to see if we can remove the GCF first. That's what we did last week. Remove the GCF, and then we factored the trinomial into two binomials. So in some cases today, we're going to have to remove the GCF. And then we're going to take the square root of the first and the last term. We're going to write it as two binomials factored. And remember, they have to have opposite signs. So one's going to be a plus and one's going to be a minus. Okay, let's look at the first example. Okay, so can we take the square root of x squared? Yes, because x squared is x times x. Can we take the square root of 49? Yes, because 7 times 7 is 49. Is it a subtract? Yes, that means that this can, in fact, be factored. So it becomes two binomials. If we take the square root of x squared, we get x. So our first terms become x in both binomials. If we can take the square root of 49, it becomes 7. That means the two second terms are a 7. One becomes a plus and one becomes a minus. Okay? And it's as easy as that. Okay? It doesn't matter. You could have written the minus first and the addition after that. Okay? Now, this one does look a little bit more complicated, okay? Can we take the square root of the first term? Well, yeah, we can take the square root of the 25, it's 5 times 5. And we can take the square root of the a squared, that's a and a. Well, what happens? We have a 5a and a 5a. So if we can do that, our first terms become 5a and 5a. Can we take the square root of the second term? Well, 81 you can take the square root of, and that becomes 9 times 9. B squared becomes b times b. So we've got a 9b and a 9b. So our two terms are, second terms are 9b and 9b. Is it a subtract? Yes. So that means this is in fact factorable, and one gets a subtract and one gets an add. Okay? Let's look at the third example. Can we take the square root? Yeah, this is going to be 2y times 2y. Because the square root of 4 is 2, the square root of y squared is y. Can we take the square root of the second term? Yeah, the square root of 25 is 5, and the square root of x squared is x. So this is going to be 5x and 5x. So that would mean the first term is 2y. The second term is 5x. Now, the problem here is that this is not a subtract. So in fact, even if you can take the square root of the first term and the last term, this doesn't work. This is what we would call not factorable. Okay, you can abbreviate this as NF if you have a question like this. And there will be some that is not factorable. Now, we could have looked at that a lot sooner, and we could have said if there's an add in the middle, we can automatically remember that this is going to be not factorable. Okay, let's look at the fourth example here. Now, in the fourth example, we can't take the square root of 50, and we can't take the square root of 8. That does not mean that this is not factorable. You may have to look for a GCF first. So remember, greatest common factor, we're going to break down 50 into 2 times 25. And 25 breaks down into 5 times 5. So we've got 2, 5, and 5, and then we've got y times y. The second term, 8 divides by 2 to give you 4. And then 4 can be broken down into 2 times 2. Now we do have something in common here. The 2's are in common, so that's going to be our GCF. Now, when we look at what's left, were we able to take the square root? Yeah, because you've got 5y and 5y. So in fact, those are repeating twice. And we've got 2 and 2 repeating. Now, you could put that back together and you could say 25y squared subtract 4. Okay? Once you've factored that out, because 5 times 5 is 25 and y times y is y squared. And then 2 times 2 is 4. But you should recognize this, in fact, that you can take the square root. And that means that this would break down into 2 binomials, because it's got the subtract in there as well. So you bring down your GCF. The first terms are the square root of 25y squared, which is 5y and 5y. Take the square root of 4, and it's 2 and 2. 1 is an add, and 1 is a subtract. Now, you should be able to see the repeating patterns here for squares as well. All right, let's look at one last one here. Oh, we got a couple. 2 more. Okay. Excuse me. Can't take the square root of 12, but again, doesn't mean that it's not factorable. We may have a GCF here. So what's common? 12 breaks down into 2 times 6, and 6 breaks down into 2 times 3. Okay? Then we've got an A, and then we've got 2 B's. For the second term, 27 divides by 3 to give you, in fact, 9. And then 9 breaks down into 3 times 3. And then we've got what? An A, and then we've got 2 C's. So what's common? Okay, I see a 3 that is common in both. and I see an a that is common in both. So 3 and a can be taken out as the GCF. Now, what you're looking for is, in fact, things that are repeating twice. That tells you that you can take the square root. If it's easier for you to just put it back together, then let's put it back together. So 2 times 2 gives us 4, and b times b gives us b squared. Taking the square root of that, right, is in fact 2b times 2b. So that's going to be our binomials, 2b and 2b. Now, taking out our 3a, and we got 3 times 3, which is 9, and c times c, which is c squared. Now, there is that subtract in between. So now, again, you should recognize that you can take the square root of 9c squared because you're getting your repeating here, 3 times 3 and c times c. So we're going to have 3c and 3c. Those are going to be our last terms. One has an add and one has a subtract. This bringing down of our GCF, this becomes our final answer. Okay, the GCF and then the 2 binomials, right? Whoops. And one has an add and one has a subtract. Okay, it only works because we have a subtract in the middle. We can take the square root of the first and the last term. Okay, one last one here. Now this one is much more complicated. Okay, and I want to throw it in there because this is something you're going to need for grade 10 next year. So we're going to start with looking at whether we can in fact take the square root. Yeah, it's got a subtract. And taking the square root of 81 is, I'm hoping you know, is 9 times 9. And taking the square root of a to the fourth is, or sorry, x to the fourth is x squared times x squared. So we can take the square root of that, okay? So that means we're going to have 9 and an x squared in each of these terms, or each of the binomials. So 9x squared and 9x squared. We have to be able to take the square root of the second term. So what is the square root of 16? Well, that is 4 times 4. And again, the square root of y to the fourth is going to be y2 times y2. So our second terms are going to be 4y squared and 4y squared. Now, remember, one has an add and one has a subtract. Now, this is a trick where, in fact, we can factor this down farther. I'm hoping you recognize that this one doesn't factor any farther because it has an addition. So we know that one can't factor farther. This one is going to stay 9x squared plus 4y squared. That quickly eliminates it from being able to factor down farther. Let's look at the second one. Okay, this one has a subtract, so that's looking factorable as a perfect square. Can we take the square root of the first term? Well, in fact, we can. We can take the square root of 9 and we can take the square root of x squared. So that would break down into the square root of 9 would give us 3 and 3. And the square root of x squared would give us x and x. Can we take the square root of the second term? Yeah, because the square root of 4 is 2. So we'll put a 2 here, and the square root of y squared is y. So now this gets broken down into 2 binomials farther. Remember, one has an add and one has a subtract. Now we can't go any farther because we can't take the square root of 3 or 2. So we know we're done. Okay? So this one, in fact, gets factored down to 3 parts. Okay? Just like the one up above had 3 factors. The greatest common factor and then the 2 binomials from the perfect square. This one became two binomials from the perfect square, but then one of those binomials, the one that has the subtract, could be broken down farther in because it's a second perfect square. Okay, and again, 1, 2, 3 terms. So a question like this one is going to be worth 2 marks. Also a question like the GCF. You get 1 mark for taking the GCF out and 1 mark for finding the 2 binomials. All right, your assignment is due on Friday. Take care, everyone, and I should have your report card marks out the following week, right? All right, bye-bye.